Hello students. So today we'll be solving some MCQs questions based on work, power and energy. तो चलो स्टार्ट करते हैं फ्रॉम क्वेश्चन नंबर क्वेश्चन 1 और 2. यहाँ से देखो. So the potential energy of a body is given by A minus bx square, where x is the displacement, the magnitude of the force acting on the particle. अच्छा, तो यहाँ पे जैसे कि आप देख पा रहे हो कि पोटेंशियल एनर्जी इज गिवन बाय A minus bx square. Okay, so I can write we know that change in potential energy is given by negative of what done by the conservative force. This is an important relation, you might be knowing these things. Okay, तो ये हम रिलेशन यूज करेंगे. ओके, तो ये रिलेशन यूज करके हमें निकालना है. दैट इज u तो दिया हुआ, दैट इज a माइनस बी एक्स स्क्वायर इज गिवन. सो आई कैन राइट du बाई डी एक्स इक्वल्स टू, या फिर माइनस डी बाई डी एक्स इक्वल्स टू फोर्स. यस, और आई कैन राइट माइनस डी यू बाई डी एक्स इज नथिंग बट इंटीग्रेशन, डिफ्रेंशिएट करेंगे पोटेंशियल एनर्जी को विद रिस्पेक्ट टू एक्स. इट विल बी ज़ीरो माइनस टू बी एक्स इक्वल्स टू एफ, or f equals to 2 times of b into x, and from here we can know that force is directly proportional to x. Okay, so option number 3 is the answer. Next question देखते हैं अभी. If the potential energy of two molecules is given by v, अच्छा, v is given by how much? a by r raised to the power 12 minus b whole divided by r raised to the power 6. So we have to find minus dv by dr, ये निकालेंगे हम. ओके, तो इट विल बी माइनस ऑफ, ये कितना हो जाएगा बताओ. ये हो जाएगा 12. अच्छा ठीक है, एक काम करते हैं, सबसे पहले इसे हम थोड़ा अरेंज कर लेते हैं. दैट इज v इक्वल्स टू a इंटू आर टू द पावर माइनस 12 माइनस b इंटू आर एस टू द माइनस 6. ठीक है, now it will be easier. Minus dv by dr will be minus 12. ठीक है, माइनस है, ठीक है, माइनस ऑफ 12 इंटू a इंटू आर एस टू द माइनस 12 माइनस 1, दैट इज माइनस 13, माइनस b इंटू माइनस 6 will be plus 6, that is 6 into b into r raised to minus 7. that must be equals to the force, और यहाँ पे दिया गया है कि it is at equilibrium, so force net force will be 0. so I can write ये हो जाएगा ये हो जाएगा, ये माइनस अंदर आएगा तो ये हो जाएगा प्लस 12a r to the power minus 13 minus of 6b r to the power minus 7, that must be equals to 0. या फिर हम लिख सकते हैं 12 into a divided by r raised to the power 13, that must be equals to 6b by r raised to the power 7. इधर कैंसिल तो r raised to the power 6 equals to r raised to the 6 equals to हो जाएगा ये 2a by b. okay, so this is the value of r raised to the power 6. ये वैल्यू इतना आना चाहिए, माइनस माइनस प्लस माइनस माइनस प्लस, और ये माइनस आ गया. ठीक है, दैट मस्ट इक्वल्स टू 0. वेरी गुड. तो माइनस डी वी टू हैव टोटल विल बी 0. ओके, r to the 6 will be 2a by b. ऑप्शन नंबर 4 इज आंसर. ओके, चलो नेक्स्ट क्वेश्चन. क्वेश्चन नंबर 104. A block of mass 1 kg moving on a horizontal surface with speed 2 meter per second enters a rough surface. The retarding force on the block is given by this one. Okay, it is from 10 to 100, and if it is less than 10 and greater than 100, then it will be 0. So obviously this is going to be a non-conservative force and this is going to be a conservative force. ओके, कंजर्वेटिव फोर्स क्या होता है, जीरो होता है, ठीक है। और जो नॉन कंजर्वेटिव फोर्स होता है वो पाथ डिपेंडेंट होता है, तो इसलिए जीरो नहीं होगा। तो यहाँ पे हम निकाल सकते हैं वर्क डन इज गिवन बाय एज इट इज ए वेरिएबल फोर्स, integration of f dot dx from 10 to 100. So work done will be equals to, इसे मैं मिटा देता हूँ यहाँ पे। So work done will be f dot dx, that is minus k by x into dx, integration 10 to 100, or work done equals to minus k into x, dx by x is nothing but ln of x, okay, that is from 10 to 100, or w equals to minus k ln of 100 minus ln of 10, or also I can write w equals minus k ln of 100 by 10. This is a property of logarithm. So w equals to minus k into ln of 10, and we can write, okay, fine. So work done is given by how much? So work done is given by minus k, k value is given 0 0.5, 0 0.5 into is minus ln 10 is approximately 2.303. So the whatever values it comes out to be, ठीक है। तो इसको अगर हम देखेंगे 5/10 करेंगे तो ये हो जाएगा -1/2 इंटू 2.303, तो ये आ जाएगा माइनस 2 1 2 2 5 10 2 1 2 1 minus 1.151, or we know that change in kinetic energy is nothing but the work done, and change in kinetic energy is k final minus k initial equals to work done, and k final equals to k initial plus work done. So k final we need to find out what is k initial. It is given mass is given 1 kg, speed is given 2 meter per second. So initial will be half mv square, half into m is m, v is 2, that is will be 4, that is going to be plus w is going to be minus 1.151. So k final will be, so it will be going to be 2 minus 1.151, or k final will be how much? 0 means it will be 9,999,953, then 953, 953, then again it will be 9918, then it will be again 8, okay. 8.839 is the final kinetic energy. So this is the answer for the, that is going to be 8 point, sorry, this is not 8 point, I'm extremely sorry, this is going to be 0, okay, 0.839, 0.839, 94, sorry, it will be 4, 974, 0.849, or I can write approximately 0.85, that is option number 3, okay. So I hope you got this. नेक्स्ट, तो इसे मिटाना पड़ेगा, इसे मिटा देता हूँ, ओके। सो नेक्स्ट क्वेश्चन नंबर 105, a particle in certain conservative force field has a potential energy U is given by 20xy by z, okay. The force exerted on it is, तो इस पे जो फोर्स लग रहा होगा कैसे लिखेंगे इसको? सो वी हैव टू टेक ऑल द थ्री कंपोनेंट्स, दैट इज एक्स वाई एंड जेड, ओके। सो वी हैव टू राइट डी यू बाय, we have to find the force, so we have to find this fx, that is du by dx, then fy, that is du by dy, and we have to find fz, that is du by dz. Obviously there will be a minus sign, okay, because these are conservative forces. So we have to find minus du by dx, du by dy, and du by dz. Okay, fine. So first of all, our duty is to find du by dx, or minus du by dx. That is minus, what is du by dx? So this is given u. We have to differentiate with respect to x. With respect to x, okay, keeping other things are constant. So it will be 20 y by z. Okay, so minus du by dy will be minus, it will be 20 x by z, then minus du by dz. Look, I'm differentiating it with respect to x, y, and z, keeping the other parameters or other variables constant. Okay, because we are doing the partial differentiation. Okay, okay, fine. Next is a du by dz. So it will be du by dz means du by dz, is it to minus 1, so it will be minus 1. So I can write 20 xy into minus 1 z to the power minus 2. Okay, this is I cap, j cap, and k cap. So I can arrange it like fx I cap plus fy j cap plus fz k cap. That must be equals to minus, I will take the minus common here. So 20 y by z I cap plus 20 x by z j cap, a minus minus common, so it will be plus, so it will be minus, obviously it will be minus. What I will write here, it's a minus sign, again it's minus, obviously it will be plus, minus 20xy by z square k cap. Okay, so this is the final answer. So let us check it. uh, so it will be minus, so this is going to be minus minus, and this is going to be plus. So minus minus plus, obviously option number 2 is the answer. Okay, so moving to the next question, I hope you have understood this. Question number 106. A particle tied to a string describes a vertical circular motion of radius r continually if it has a velocity root 3 gr at the highest point, then the ratio of the respective tensions in the string holding it at the highest and the lowest point. Okay, fine. So we have to find the tension if it has a velocity of root 3 gr at the highest point. Okay, so at the lowest point, suppose this is a string which is making a vertical circular motion. So at the lowest point, the tension acting are, that is mg downward and mv square by r. Okay, similarly at the highest point, tension acting downward, mg downward, and outside mv square by r. This is for highest and this is for lowest. Okay, so tension at the highest point, that is tension at the highest point, plus mg equals mv highest whole square by r. Okay, here r is given small r. Okay, fine, it's let us make it a small r. Okay, not a big deal. Let us change it to small r. I'm changing it to small r. Okay, then tension at the highest point is mv vs square by small r. Then I can write here, that is tension th equals mvh square by r minus mg. Okay, vh is the, here vh is the tension velocity at the highest point, that is root over 3gr. So what I can do is tension at the highest point equals to m into velocity is going to be 3g r by r minus mg, or tension at the highest point is going to be, it is going to be 3 mg minus mg, or th equals to 2 mg. Okay, tension at the lowermost point by using the equation, that is tension at the lowermost point, that equals to mg plus mvl square by r. Okay, where vl is the velocity at the lowermost point. And how to find the lowermost point velocity? From the energy conservation, from energy conservation at point at the lowest most point and at the highest point. Okay, that is energy initial equals to energy final. So initial energy is going to be, if I take the reference point at the lowermost point, then here the potential energy is going to be 0. So I can write half mvl square equals to mg into 2 times of r, that is mgh. Okay, from lowest to highest point, and plus half mvh square. Okay, so I can write here, here I can write half mvl square equals mg into 2r plus half into m vh, the velocity at the highest point, we know that the value that is given by root over of 3gr, or I can write 3g into r only. So from here 3gr, okay, 2gr. So here gonna 2 plus 3 is going to be 5. So half mvl square equals to 5 mg r divided by 3. So sorry, divided by 2, not 3, divided by 2. So here m get cancelled, 2 get cancelled. Okay, so I can have, we have vl equals to root over of 5gr. Okay, so we have vl is root over 5gr. So we have to put this value in this equation. So that is tension at the lowest most point, it is going to be mg plus m into 5gr, 5gr whole divided by r. So tension at the lowermost point is going to be mg plus 5 mg, or TL equals to 6 mg. So at the lowermost point the tension at the string is 6 mg. So it is given that, okay, then the ratio of the respective tensions in the string holding it at the highest and the lowest point. Highest and the lowest point, highest is 2 mg and the lowest is 6 mg. So the ratio of the highest to the lowest is going to be 2 mg by 3 mg. Okay, so this mg get cancelled, sorry, this is 6 mg, so it's going to be 1 by 3. Okay, tension at the highest point, I think we have done something. Tension at height is plus mg is square by r, equals to mb square by r minus mg. Okay, tension at highest point, to 3gr by r, is mg. So we did it right. I don't know what's happened to the option, but yes, we got the correct answer. Fine. So moving to the next question. Question number 123. Question number 123. So a body is thrown up with a velocity, certain initial velocity. The potential energy and the kinetic energy of the body are equal at a point P in its path. If the same body, if the same body is thrown with double the velocity upward, the ratio of potential and kinetic energies of the body when it crosses the same point. Okay. So initially body is thrown up with certain initial velocity. I think we have done these things in the work energy, uh, the previous assignment we have done these things. Okay, so I'm not going to do these things again, so please check that old assignments. This is a similar question, we have done it. The answer will be again, this answer is going to be, I think it's 1 is to 7. I think the answer will be 1 is to 7. So we did the same thing. You can check it out. Question number 123. Okay, question number 123, you can check the answer. It should be 1 is to 7. We have done it. Please go through the old assignments. And question number 124 also we have done the same thing. I think this answer is also going to be this option number 3. Okay, just have a look on that. So next is question number 125. I think we have done these things also. Yes. Okay, this is the a constant force F is acting on a body of mass m with a constant velocity v. As shown in the figure, the power P exerted is, power P is asking. So power P equals to F dot V, or it will be F V cos theta. Okay, or I can write here what is the velocity. The power is extended is the power is gained by power into velocity, obviously. Option number 1 is the answer, F cos theta into V. Okay, so next is question number, this is question number 125. Okay, question 126. Second blades turbine then must pulse. Okay, we have done these things also. Question 126 we have also done. So you will see that the answer is option number 4. We have done these things in the previous assignment. Next is question number 127. Water is falling on the blades of a turbine at a rate of 1000 kg from certain spring. If the height of the spring be 100 meter, then the power transferred to the turbine. Yes, we have done these things also. Please have a look that the answer is going to be 100 kilowatt. Okay, and question 128 we have done the same question. Okay, the answer will be 15 minutes. Please have a look on that previous MCQs questions based on the work power energy. Okay, next is question number 16. A stone of mass m is tied to a string and is moved in a vertical circle of radius r, making n revolution per minute. The total tension in the string when the stone is at the lowest point, when it is at the lowest point, you have to find the what do you say, that you have to find the uh, tension. Okay, okay, moved in a vertical circle of radius r, making n revolutions per minute. Okay, omega is given, omega is given n revolution per minute, that is n revolutions, one revolution, n revolution per minute, rpm, or I can write n into 1 revolution equals to 2 pi radian divided by, per minute is given by per second, that is 60 second. So I can write omega equals to 2 pi n by 60. This is the omega value. Okay, so it is asking total tension. So total tension will be at the lowest point. If something is revolving like this, okay, then at that lowermost point the tension will be tension T, sorry, extremely sorry, tension will be upward. Lowermost point will be mg as well as mv square by r, or I can write T equals to mg plus mv square by r, or mg plus, I can write v. What is v? We know that v equals to r into omega from the circular motion. Okay, v equals to r omega, v equals r omega. or omega equals to V by R. Similarly, we can write, or we can write V equals to R omega. So M into R square omega square divided by R. So I am getting mg plus m into R square into 2 pi, means it is 4 pi square n square whole divided by, this is R into 60 whole square is 3600. Okay, so this is what I got. uh, Next tension, here mass is common, g plus r, here I can write n square into pi square divided by 4 9 36 00. Okay, pi r square n square pi square into r by, okay fine, option number D is the answer. Okay, next question. So इसे मिटाना पड़ेगा for next question. So I'm rubbing this one. Question number 17. A stone of mass 1 kg is tied to a string 4 meter long and is rotated at a constant speed of 40 meter per second in a vertical circle. The ratio of the tension at the top of the and the bottom. Okay, तो यहाँ पे एक स्टोन है जो कि टाइड हुआ है एक स्ट्रिंग से, तो हमें निकालना है कांस्टेंट स्पीड से मूव कर रहा है ये इन ए वर्टिकल सर्कल. ओके, लुक, हम क्या कर सकते हैं, इसको पहले एक सर्कल बनाएंगे, ठीक है, एक लोअर मोस्ट पॉइंट दिखाएंगे, एक हाईएस्ट मोस्ट पॉइंट दिखाएंगे, ठीक है. फॉर हाईएस्ट पॉइंट, दिस फॉर लोएस्ट पॉइंट. नीचे लग रहा होगा एम जी, एम वी स्क्वायर बाय आर, और यहाँ पे लग रहा होगा, यहाँ भी लग रहा होगा एम जी नीचे, एम वी हाई स्क्वायर बाय आर. ओके, सो रेशियो निकालना है. सो टेंशन एट द हाईएस्ट पॉइंट इक्वल्स टू एम वी स्क्वायर बाय आर माइनस एम जी. ओके, कांस्टेंट स्पीड है तो इसका मतलब यहाँ पे v कितना है, 40 हो जाएगा. तो मास इज गिवन 1, सो 1 इंटू 40 मतलब 1600 होल डिवाइड बाय आर का वैल्यू कितना दिया हुआ है, आर का वैल्यू दिया हुआ है क्या, 4 मीटर. ओके, 4 माइनस मास इज अगेन 1, g is not given, so I'm taking g as 10. Okay, tension at the highest point will be 4 4 is 16, 400 minus 10, that is going to be 390 Newton. Similarly, I can find the tension at the lowest point is equals to mg plus mv lowest whole square by r, और टेंशन एट द लोएस्ट पॉइंट विल बी, तो ये माइनस था, सिर्फ ये प्लस हो जाएगा, बात बराबर है, सो इट विल बी 410 न्यूटन. सो द रेशियो द टेंशन एट द टॉप एंड द बॉटम, सो टॉप एंड बॉटम, टॉप मतलब हाईएस्ट बाय लोएस्ट, इट विल बी 390 बाय 410. सो एक 0 0 काट जाएगा, 39 बाय 41. आंसर ऑप्शन नंबर बी. ओके, नेक्स्ट क्वेश्चन नंबर 18 देखो. A weightless thread can bear tension up to 3.7 kg weight. ठीक है. A stone of mass 500 gram, a stone of mass 500 gram is tied to it and revolved in a circular path of radius 4 meter in a vertical circle. If g equals to 10, then the maximum angular velocity of the stone will be, maximum angular velocity पूछा है उसने. So maximum angular velocity कहाँ पे निकल सकता है बताओ, दैट इज ओमेगा इक्वल्स टू v बाय आर. अच्छा, रेडियस तो कांस्टेंट है, अगर स्पीड कांस्टेंट मतलब स्पीड अगर जहाँ पे ज़्यादा रहेगा ओमेगा भी क्या होगा, ज़्यादा होगा. तो दिस इज द टेंजेंशियल स्पीड. ओके, दिस इज द टेंजेंशियल स्पीड, दिस वन इज द टेंजेंशियल स्पीड. तो टेंजेंशियल स्पीड जितना ज़्यादा होगा ओमेगा भी उतना ज़्यादा होगा। टेंजेंशियल स्पीड कहाँ पे ज़्यादा होता है सबसे, इट इज़ ज़्यादा लोअर लोअर मतलब लोअर मोस्ट पॉइंट। ओके, तो लोअर मोस्ट पॉइंट पे अगर ये ज़्यादा होता है तो हम यहाँ निकाल सकते हैं दैट इज़ दिस वन एट द लोअर मोस्ट पॉइंट। यहाँ पे टेंशन रहेगा ऊपर, नीचे रहेगा एम जी, और सेंट्रीफ्यूगल फोर्स एक्ट कर रहा होगा दैट इज़ एम वी स्क्वायर बाय आर। सो आई कैन राइट टी इक्वल्स टू एम जी प्लस एम वी स्क्वायर बाय आर। ठीक है, तो यहाँ पे कुछ वैल्यू पुट करते हैं। टेंशन हमें क्या निकालना, क्या है हमें टेंशन दिया हुआ है ना, यस टेंशन दिया है 3.7, दैट इज 3.7 इक्वल्स टू मास कितना दिया हुआ है, मास इज 500 ग्राम, दैट इज 1/2 kg, जी दिया है 10 प्लस अगेन मास इज गिवन 1 सॉरी 1/2 इनटू वेलोसिटी कितना दिया है स्पीड, अच्छा स्पीड नहीं दिया, हमें स्पीड निकालना है दैट इज वी स्क्वायर बाय आर। आर कितना दिया है, आर इज गिवन बाय 4। ठीक है, तो मैंने यहाँ पे लोअर मोस्ट पॉइंट के लिए इक्वेशन लिखा है क्योंकि लोअर मोस्ट पॉइंट पे v ज़्यादा होता है, तो v ज़्यादा होगा तो ओमेगा भी यहाँ पे ज़्यादा होगा। ठीक है, तो यहाँ पे हम कर सकते हैं 2 5 10। ओके, सो v स्क्वायर बाई 8 इक्वल्स 3.7 माइनस 5, 3.7 है ना, के जी वेट। ओके, कैन बेर टू के जी वेट। अच्छा 3.7 kg वेट है ये, 3.7 kg वेट मतलब ये हो जाएगा, ये हो जाएगा 3.7 जी, 3.7 जी। ओके, 3.7 जी मतलब ये हो जाएगा 3.7 इंटू 10 माइनस 5। सो वी स्क्वायर बाई 8 इक्वल्स 37 माइनस 5, और वी स्क्वायर इक्वल्स टू ये हो गया 32 इंटू 8, और वी स्क्वायर और वी इक्वल्स टू हम यहाँ पे लिख सकते हैं वी इक्वल्स टू रूट ओवर ऑफ 32 इंटू 8। ओके, और वी इक्वल्स टू कितना आ गया देखो, 4 इंटू 8, 4 इंटू 8 इंटू 8, और वी इक्वल्स टू 4 का रूट 64 का रूट, इट विल बी 8 इंटू 2, सो इट विल बी 16 मीटर पर सेकेंड स्क्वायर, 16 मीटर पर सेकेंड नॉट स्क्वायर, 60 मीटर पर सेकेंड इज द वेलोसिटी। लेकिन हमें वेलोसिटी नहीं निकालने नहीं दिया है, हमें दिया है मैक्सिमम एंगुलर वेलोसिटी। तो एंगुलर वेलोसिटी कितना हो जाएगा, ओमेगा इक्वल्स टू वी बाय आर, 16 बाय आर है 4, इट विल बी 4 रेडियन पर सेकेंड, आंसर विल बी 4 रेडियन पर सेकेंड। ओके, चलो वेरी गुड। अगला क्वेश्चन देखते हैं, क्वेश्चन नंबर 19। A 2 kg stone at the end of a string 1 meter is whirled in a vertical circle at a constant speed. The speed of the stone is 4 meter per second. The tension in the string will be 52 Newton when the stone is, अच्छा स्टोन कहाँ पे होना चाहिए, टेंशन इन द स्ट्रिंग ये है when the stone is at the top या bottom या halfway या फिर none of the above। ठीक है, चलिए उससे सॉल्व करने से पहले मैं इसे मिटा देता हूँ because due to lack of space। थोड़ा अच्छा भी दिख रहा है ना, मिटाते हैं तो ठीक है। क्वेश्चन नंबर 19, ए 2 kg stone at the end of string 1 meter long is whirled in a vertical circle at constant speed. The speed of the stone is 4 meter per second। ओके ओके ओके, कांस्टेंट स्पीड से मूव कर रहा है, ठीक है ना। द टेंशन इन द स्ट्रिंग विल बी 52 न्यूटन। तो 52 न्यूटन अगर है तो ऑब्वियसली 52 सबसे ज़्यादा कहाँ पे होगा भाई, बॉटम में ही होगा। ठीक है, तो चेक करते हैं। ठीक है, बॉटम में चेक करते हैं पहले। अगर मान लो ये ऐसा है तो बॉटम में चेक करेंगे, टॉप में चेक करेंगे और हाफ वे में चेक करेंगे। ठीक है, तो बॉटम में क्या बताओ, टी इक्वल्स टू एम जी प्लस एम वी स्क्वायर, और टेंशन मान लेते हैं यहाँ पे दिया है 52। ठीक है, 52 आना चाहिए यहाँ पे। सो मास कितना है यहाँ पे 2 इंटू जी कितना ले लेते हैं 10 प्लस 2 इंटू वी कितना भाई, सॉरी एम वी स्क्वायर बाई आर, वी कितना यहाँ पे दिया है 4 मीटर पर सेकेंड, दैट इज 16, और 1 मीटर लॉन्ग है ये। सो इट विल बी 20 प्लस 32, इट इज गोइंग टू 52 न्यूटन। यस, आंसर इज एट द बॉटम ऑफ द सर्कल। ठीक है, एक ही बार में आंसर आ गया। अगर नहीं आता तो शायद ऊपर भी चेक करते और बाकी जगह पे भी चेक करना पड़ता। ठीक है, चलो अगला क्वेश्चन देखते हैं। क्वेश्चन नंबर 20। An object is tied to a string and rotated in a vertical circle of radius r. Constant speed is maintained along the trajectory. Okay. Then v square by rg क्या होगा? v square by rg क्या होगा? मैक्सिमम मिनिमम, चलो कोई बात नहीं। मैक्सिमम कहाँ पे होगा? नीचे। ठीक है, तो मैक्सिमम अगर नीचे होगा, यहाँ पे दिया है कॉन्स्टेंट स्पीड दिया, अच्छा ठीक है। मैक्सिमम मिनिमम, मैक्सिमम हो जाएगा एम जी प्लस एम वी स्क्वायर बाय आर। लोअर मोस्ट पॉइंट के लिए मैं निकाल रहा हूँ मैक्सिमम। ओके, और हो जाएगा टी मिनिमम, टी मिनिमम विल बी एम वी स्क्वायर बाय आर माइनस एम जी। ओके, और इसका रेशियो दिया हुआ है कितना, इसको डिवाइड कर देंगे, इसको भी डिवाइड कर देते हैं। ठीक है, इसका रेशियो कितना आएगा, दैट इज गिवन बाय 2। मैक्स बाय मिनिमम इज गिवन बाय 2, या फिर हम लिख सकते हैं इसे एम जी प्लस एम वी स्क्वायर बाय आर इक्वल्स 2 टाइम्स ऑफ एम वी स्क्वायर बाय आर minus 2mg, or I can write mg minus 2mg, it will be 3mg minus mv square by r equals to 0, or 3mg equals mv square by r, m get cancel, v square equals to 3rg. So it is given to find the ratio of v square by rg. So v square by rg will be 3. I think you got this. Okay, answer will be 3. P its acceleration when the string is horizontal. String जब horizontal रहेगा तो अच्छा ठीक है। चलो सबसे पहले एक ड्रॉ करते हैं एक सर्कल, दैट इज द स्ट्रिंग्स नेक्स। ओके, so these are the points, or let me draw the two given points only, that is horizontal point and the topmost point. Okay, तो यहाँ पे हम देख सकते हैं, मान लेते हैं ये रेडियस r है। ठीक है, this is the velocity at the horizontal when the string is horizontal, and this is the velocity when the string is at the topmost point. Okay, so it is given the object just passes the topmost point with velocity root over of rg, sorry, root over of rg, r into g. Is it so? Yes, critical velocity, because root over rg is the critical velocity that the object will pass through the topmost point. Okay, so if this is the critical velocity, then tension must be equals to 0. At critical velocity, tension will be equals to 0. So the equation here I can write, it will be mg downward, topmost point will be mvt square by capital R. So it will be how much? That is mg must be equals to mvt square by R. So get cancel out. So g into R will be how much? Yes, vt square equals to root over rg. Yes, that is vt square. Okay, so what we can do, we can apply the energy conservation from point, the horizontal point, to this point. Okay, this height is nothing but this is the r. Okay, so energy initial equals to energy final. So energy initial at this point, so let us take it as a reference point. If reference point, this is the reference point, the potential energy will be 0 here. So here we have a 0 plus, here the we have kinetic energy, that is half m vh square, that must be equals to potential energy at the topmost point, that is mg into r plus half mv t square. Okay, and we don't know about h, that is half m vh square must be equals to mgr plus half into m into rg. Okay, so we can write mvh square equals 2 plus 1 3 mgr. Okay, so here m get cancelled, vh will be root over of 3gr. This is the velocity at the horizontal point. So but we are interested in finding the acceleration. So what we will do, okay fine, we can also write it like this. Let me write like this: vh square equals to 3gr, or acceleration acting at the horizontal axis, that is a centripetal acceleration. This one is a centripetal acceleration here toward the center, and centripetal acceleration is given by v square by vh square by r, or I can write 3gr by r, or 3g. Okay, this is the acceleration. So answer will be option number C. Okay, next. So this one I have done. You can check the concept video. I have done the same problem here. The answer will be 15 by 4. Okay. Option number 22. I think we have done it. I've done the same problem. Let's have a look. Question number 22. Okay. No, I think the answer should be option D. Okay. Just check it. The same type of problem is this one. That is, we'll get the maximum value of r. Okay, for the body to successfully complete the loop. So okay, we'll do one thing. Let us do this. Okay, so here the potential energy here is converted into kinetic energy. Okay, so frictionless track is there, ends in a circular loop of radius r. Figure, okay, body slides down the track from the point A, which is at a height of h 5 centimeter. Maximum value of r for the body to successfully complete the loop. You have to find the maximum value of r. Okay, so we have to use the energy conservation. Okay, if it successfully completes the loop, then the minimum velocity at point B, that must be vb must be equals to root over of 5rg. Okay, and the potential energy at point B, energy conservation, energy at initial here, energy final here, it must be conserved. So initial energies, we have only potential energy, that is mgh, that must be equals to, here we have only kinetic energy, because this is the reference point, and at the reference point potential energy will be 0. Okay, so mgh equals to half m vb square. Okay, or we can write g into h equals half vb square equals to 5rg. G cancel, so h is going to be 5 by 2r. So we are interested in finding the r value, that is 2h by 5. H is given 5, so answer will be going to be 2 centimeter. Okay, very easy one. So next question, question number 23. Just have a look on this. A simple pendulum oscillates in a vertical plane. Okay, when it passes through the mean position, the tension in the string is 3 times the weight of the pendulum bob. Okay, so weight of the pendulum bob, suppose m is the mass of the pendulum bob, so the weight is going to be mg. Okay, now it is saying that the tension is 3 times the weight, that is 3 times mg. Okay, so what is the maximum displacement of the pendulum with respect to the vertical? So it is asking that what will be the maximum displacement. Okay, so let me draw here. So it is oscillating like this. Okay, this tension here, this is acting mg, and this tension equals to 3 times of mg. So now it is asking what is the, suppose this is angle theta, so what is the maximum displacement of the pendulum with the vertical. So from the vertical, okay, from the vertical, what is the maximum displacement? It's asking this height. Okay, from here to here, maximum displacement. It is asking the height, maximum displacement. Okay, so in this case, what we can do, let us assume, um, okay, let me rub this one. We don't have space here. Let me rub this one, or I can take another one. What I will do, okay, let me rub this one. Okay, so I'm writing the data here. So we have got T equals to 3 mg. Okay, so what I will do, we'll write the equations for the tension, that is tension equals to mg plus mv square by r is the radius, suppose length. Okay, this is the equation of tension at the lowermost point. So tension is given as 3 mg equals to mg plus mv square by r, or I can write 2 mg equals mv square by r, m get cancel out, so v square equals to 2gr. Okay, so now using the energy conservation, okay, by using the energy conservation, what we can do is, we have to find the maximum displacement. So so let me draw here. This is the, suppose this is the pendulum bob. Okay, and it makes an angle like this, that is, this is theta. So it is given to find this height, this length. This is nothing but, if total is r, okay, this is going to be r cos theta, this is going to be r minus r cos theta. We have done these things in our conceptual videos, yes, so you can refer that also. So by using the conservation of energy from this point to this point, okay, the ground point will be have on, will have only the kinetic energy, that is half m v square. That must be equals to, here we'll have both the energies, that is half m, suppose let it be v1 square plus mg r minus r cos theta. Okay, is that clear? So at this point we have to find the velocity. So what we will do is, um, what we can do is, here we don't have the kinetic energy, yes, at the highest point. Acha, at the highest point, listen, at the highest point, the potential energy, sorry, the kinetic energy also going to be zero. Yes, it is also going to be zero. So we have only half mv square equals to mg r minus r cos theta. So v square, we know the value is 2gr, that is half into m into 2gr equals mg r minus r cos theta. So here m get cancel, g get cancel out. Here I will get 2 to get cancel out, r is common, so 1 equals to 1 minus cos theta, or I can write 1 minus 1 equals to cos theta, so cos of theta equals to 0, or theta equals to 90 degree. So answer will be option number D. Okay, so this is the maximum displacement when theta equals to 90 degree, means it will come to this place, it will come to this place. Is that clear? Okay, fine. So moving to the next question. So this is a similar question, you can do it. This is a very similar question, and this question I have done it. Okay, in my conceptual video you can see it, the same question. Okay, and question number 26, this is the conceptual based question. That is, it is given that the net acceleration, first bit, the net acceleration of the particle in the circular motion is always along the radius of the circle towards the center. No, 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 wrong. Then the velocity vector of a particle at a point is always along the tangent to the path of the particle at that point. Yes, it's correct, correct, correct. Velocity vector is always going to be tangent. Okay. Then the acceleration vector of a particle is uniformly circular motion averaged over one cycle in a is a what is that? Hmm, hmm, hmm. The acceleration vector of a particle in uniform circular motion averaged over one cycle is a null. Yes, it's a null vector. Yes, it's correct. Option number 2 and 3 both are correct. Option of B. Okay, because look, first is correct because tension is always tangent to the circle, and the second one is the acceleration vector of a particle is uniformly in uniform circular motion averaged over one cycle is a null vector. Yes, obviously it is null vector because acceleration, we are not taking the average value. Okay, because acceleration is a, okay, because it is asking about this is the acceleration vector, and acceleration vector means it doesn't have it has a direction, and for a complete cycle its initial and final position both are same, so obviously the acceleration will be zero, or it is a null vector. Understood? So moving to the next question, this is the last questions of our session. Question number 28. A body of mass 1 kg is rotating in a vertical circle of radius 1 meter. What will be the difference in its kinetic energy at the top and the bottom of the circle? Okay. Difference in its kinetic energy at the top and bottom of the circle. So suppose if this is rotating like this, what will be the difference in its kinetic energy? Mm, okay. So at the lowermost point, let us say that it is having velocity of VL, and at the highest point it is having velocity of VH. Okay. So let us take the energy conservation. So at the lowermost point, let us say that it is having half VL square equals, and at the highest point it is having only the potential energy, and simultaneously it will have the kinetic energy also. So half m vh square plus mg into 2r. So let us say that it is having the critical velocity. Just it is just about to cross it. So I can write here vh equals root over of rg. Okay, and vl equals to root over of 5gr. Okay, so this is the minimum velocity at the lowermost point, and it is the minimum velocity at the highest most point. Okay, let us take the minimum condition for the vertical circular motion. So what I can write is half into m into vl, I can write 5gr equals half into m into vh can be written as r into g, or r into g, plus m into g into 2 times of r. Okay, so this is going to be m 5 by 2 mgr equals, so here mgr by 2, so 2 to 4, so it is going to be 5 mgr by 2. Yes, the difference is going to be difference is asking the difference. Yes, it is asking the difference. Mv square equals to mg into 2r, so it will be going to 5 by 2, 2 to the 4, 4 plus 1, it's going to 5 mgr by 2. So the difference is going to be difference in the kinetic energy. Sorry, it is asking the difference in the kinetic energy. What we have done, difference in the kinetic energy. difference in the kinetic energy. Difference means this is the highest and this is the lowest point. Okay, obviously the lowest point will have the maximum kinetic energy. So half mvl square minus half mvh square. There is no need of taking this limiting value. Okay, no need of taking this limiting values. We can directly do like this, equals to this is going to be mg into 2 times of r. Okay, this is the kinetic energy at the lowest most point, and it's the highest most point. So mass is given how much? 1 kg into 10. Radius is given 2 times of 1. So 20 joules is the difference. So try to understand the question and then solve it. So this is all about today's session. I hope you have enjoyed it. So in the coming classes, we'll do some more problems